One of the new features added into ASAP 2009 is a digitizer. The digitizer can be used to take data from any Cartesian graph and give you effectively the X and the Y values. It also has the capability of digitizing smartly for particular ASAP commands where digitization might be a useful tool. Let me show you how the digitizer works for a couple of specific ASAP commands. I'm going to start with my ASAP basic template. And the first thing I might want to do is define a media. But rather than using an index of refraction or a dispersion formula, maybe what I have available to me is simply a chart of data or a graph. So let me delete this. What I'm going to do is enter the ASAP media command, highlight that command, and you'll notice up on the ASAP menu bar there's now an item called Tools. What I'm going to do is digitize the input specifically to my INR file. So what this will do is ASAP understands that I'm interested in a media command, so it's going to digitize the data in an appropriate format for that command. So let's start our digitizer. And the first thing I can do is tell ASAP which graphic file to open up. So let me select an image I have for a refractive index curve. And as you see, here's simply my curve of index of refraction information versus wavelength. I also have the option of selecting points freely, or I can select data at a fixed interval. I tend to prefer to do things at the fixed interval, so what I'm going to do is digitize this data from 400 nanometers to 800 nanometers in 50 nanometer increments. So I'll now just click on OK. The next thing I need to do is let ASAP know what range of data I'll be covering. And you'll notice my cursor has turned into a crosshair. So I'm simply going to find some reasonable limits for the data, and holding down my left mouse button, I'm going to scroll and select a range of data that has limits that I know. I'm just going to now release the mouse button, and now I can enter the information. And you'll notice that my maximum Y value on this curve is 1.69, and the minimum is 1.62, and I selected an X range of 400 to 1200. Now, you'll also notice down here that ASAP is indicating that it knows we're taking index data, so I'm going to click on OK. And you'll notice I have a series of little markers here that I will simply move. They're fixed in the wavelength or the X direction, and all I have to do is drag them up to intersect the graph. And you'll notice they're hollow in the center, so it's very easy to see when I have the marker in the right location. I can also blow up the data and zoom in a little bit so I can get higher resolution. And I'm just going to move up my data points and just fit the curve as best as I can. Now I might decide here that maybe I need to move this point a little bit. And if I felt I needed to add an additional data point to get a better fit, all I have to do is click on the curve. And again, the data point is fixed in the wavelength direction, and I can just adjust it until I feel it's properly intersecting the refraction curve. Okay, and let me minimize this down. And a couple of other options. I can get the floating data values as I go across by clicking on this little checkbox. I could also use extended cursors, which I find much more useful when I'm doing free data rather than the fixed data intervals. But now that I've selected all of my points and represented the curve appropriately, I'm just going to click on the checkbox that says Get Data. And now I have some options as to the number of digits, if you will, I want to assign to each one. And I just need one digit after the decimal point for the wavelength, but I'd like 6 decimal accuracy on my index. And for the index, I'd like to have it right padded with zeros to have equal length data strings. Now I just will click on OK. And since it's an index, ASAP needs to know the material name, so I'm simply going to give it that data. Click on OK. And the first thing ASAP will do is create a separate file that has both the wavelength as well as the corresponding media values. And if I scroll across in my window here, you can see all of the data. If I wanted, I could save this information maybe to a library file so I could reuse it in the future without digitizing. But right now what I want to do is insert this data in my INR file. So I'm just going back to the original INR file. You'll notice I still have media highlighted. And again, I'm going to go to Tools and simply insert the digitized data. And now I have both my wavelength as well as my index values and my media name in proper ASAP format inserted directly into my ASAP script. Another common use for the digitizer might be to bring in an apodization curve for something, for instance, like an LED. Again, we'll show you an ASAP context-sensitive use of the digitizer. So I'm simply going to enter the ASAP command apodize direction. And again, highlight the command, go to Tools, Digitize as INR, and select my LED intensity map. Click on OK. And here's the data. Again, we're going to look at the Cartesian curve of the data. We will get the intensity distribution as a function of angle of incidence from 0 to 90 degrees. So let me set my interval range here, 0 to 90 in 10-degree intervals, and click on OK. And again, I'll set my range of the data with the crosshairs. And this looks pretty good. So my Y max is 1, and Y min is 0, and my X goes from 0 to 90 degrees. And we'll click on OK. And again, we'll simply take the data points and adjust them to match the curve. And there we go. And again, we'll just get the data for the intensity curve. For my angle, I'll only use 1 decimal place. For the intensity, I'll just stick to 4, but right pad with zeros to get uniform data representations, and click on OK. And as you see, we have our file with the intensity as a function of the sine of the angle. We could save this as a library file for later use, but right now let's insert the data within our ASAP INR file. So again, with apodize direction highlighted, I'm simply going to go to Tools, Insert Digitize Data, and now we have our data in proper ASAP format inserted for us right in our ASAP file. For now, the context-sensitive digitization is limited to media and apodize commands, as well as several forms of the coding command. We do plan on expanding these capabilities in future releases of ASAP. Sometimes you just have data that you need to digitize for some other application. Notice we have the ASAP commands, but we also have options for a 1 or 2 line generic. And what we have here is simply the average temperature in Tucson, Arizona. So here's my data, and now I have my axis information as well as the data, and I can choose to save this as columnar or row forms of information, and let's just select columnar data. So now what we have are the average daily temperatures in Tucson. So for those of you who live in countries outside the United States, you can see that indeed our weather can get quite warm in the summer. However, it's a dry heat.